Hi, this is Dr. Lennon, and we are going to be working with the multiple regression model. So I'm going to do the example out of the book, Butler with Deliveries. So in Excel, that gives us the Butler Trucking Company again, and we've got the number associated with each truck. There's actually about 300 of them. Miles, which we're going to treat as one of the dependent variables. Deliveries, another dependent variable, and time. So what we want to do is we want to use the multiple regression model to try to do this. So again, using that extra, first you're going to want to click data, and then remember from one of the previous videos where we first did regression and analysis, we installed this data analysis tools add-on. So we're going to click that, and we're going to go down to regression like before and click OK. And for the input range, we want to, like we said, time is the independent variable. So what we want to do, let's pretend like I hadn't done any of this before. So normally it starts off something like this. So for the independent variable, we want to highlight that whole column that contains it. So I'm going to scroll all the way down to the bottom. I just like to highlight from the bottom. It seems to go a little faster. And then highlight till you get all the way to the top. There you go. So that's the input range for the y value. And now we want the two x values. Sorry, that was the dependent variable time. The independent variables are miles and deliveries, and again, we want to highlight those as the two x values, x1 and x2. And basically, we're going to build a linear model in two variables to model this. That's what this multiple regression is going to do. It's going to give us y equals some constant plus a constant times x1 plus a constant times x2. So now everything's selected. And notice that this time when I did it, I actually highlighted the first row. If I click labels, what that'll do is it will go ahead and not count the first row as data, but actually just use the first row as labels. So we'll see miles, deliveries, and time if we would go ahead and do the regression. And then confidence level for this one, I'm going to do 99%. Again, that varies. New worksheet apply, and then we just click OK. And then we're actually basically all done. So one of the ones on the quizzes has a similar thing. It asks you to find the regression model. So how do we find the regression model? I'm just going to space these out a little bit so you can see them a little easier. But the regression model is coming from right here. These are our parameters, our coefficients. So if we wanted a model, it would look something like y equals, okay, and then remember the intercept is just the regular number. So that's going to be, if I rounded 3 decimal places, 0.127 plus the miles, 0.067, and we'll call that x1. And then the next variable coefficient is 0.689. We'd actually have to round up, so let's call it 0.690, and then say that's times x2. And then this would be our multiple regression model. Y equals 0.127 plus 0.067 x1 plus 0.690 x2. This little underscore I'm putting is just denoting the fact that these are two different letters, x1 and x2. They're not actually numerical values. It's just something different to name the variables. And then on the quiz, normally I ask something like, use the f-test to determine if there's a relationship between the variables. Well, actually, all the information is given right here in this table. So the f-test is this ANOVA test right here. And you'll see that we have this f coefficient. So if the f value is very, very large, that's telling us that this p-value for the f-test is very, very small. So the conclusion, basically your null and alternative hypothesis for an overall regression relationship would say, the null hypothesis would say all the values, b1 and b2, in this case the parameter with x1 and the parameter with x2 are all 0. Otherwise, we're going to reject that and say that there is an overall relationship. So our level of significance, since we did 99% confidence interval, is 0.01. This p-value is 2.24 times 10 to the negative 110th power. So that's a very, very, very small number, very close to 0. So that tells us in this case we're going to reject the null hypothesis, which tells us there is an overall relationship between the parameters. And then normally I ask you to use a t-test to test what the hypothesis that each one on its own is 0. So again, those p-values are right here. So we're going to ignore the one for the intercept because that's not paired with a variable, but the miles and the deliveries are, and the null hypothesis would be that for when we're doing x1, the parameter associated to miles, 0.067, that would be like our b1 value. We would say the null hypothesis is that b1 is 0 or beta 1 is 0, and the alternative is that it is not. So notice the p-value here is again very, very small, much lower than 0.01, essentially 0. So we'd reject that null hypothesis, do the t-test, and say it's not 0. And similarly for beta 2, we have 2.85 times 10 to the negative 69th. So when we have that relationship, that's how we're using the t-test to get those values and convey information. So I hope that helps you kind of understand how we get the multiple regression model and how we have an f-test relating all the variables. We could have more than 2. We could have 10 if we had a really complex set of data, and then we can test each one individually. So good luck on that first quiz question.